Hello students, how are you all? I hope everyone fine. Okay, in last class we started to learn 3D geometry and direction cosines as well as two derivations over, right? Remember? So it's a continuation of that topic. First I'll recall the two formulas which we derived in the last class because very important derivations. Okay, the equation of a line passes through the point, okay, passes through the point and parallel to the vector. So idra position vector ಕೊಟ್ಟಿರ್ತಾರೆ ಏನು, what is the position vector of this? Vector A, this is a vector B, the vector which is parallel to the line. So position ಯಾವ್ದೋ ಒಂದು point, fixed point ಇರುತ್ತೆ, okay. So what is the equation? Vector equation, the vector form. ನೆನಪಿದೆಯಾ ಏನು vector form? Vector R is equal to vector A plus lambda times vector B. Remember? As well as Cartesian form. What is the Cartesian form? X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. What is x1 y1 z1? x1 y1 z1 will be the coordinates of this point, x1 y1 and z1. ABC, you know, components of this vector. Okay. What is x comma y comma z? It is a point which we are going to take, okay, as a one point on the line p of x comma y comma z. So this is a derivation we did in a last class, and usually in the questions na kelidare exam alli 5 marks ge. So 5 marks kelidaga eradu form allu keltare, derive equation in the vector form as well as in Cartesian form. Eradu form allu keltare, be ready for that. Artha agittalva proof? So next, equation of a line passes through the 2 points with the position vector, vector A and vector B. So 2 points, one line alli 2 point ಕೊಟ್ಟಿದ್ದಾರೆ, both position vector is known, position vector of both point is known. Vector form ಗೆ Cartesian form ಗೆ ಏನು ಯಾವುದೆಲ್ಲ ಬೇಕು? coordinates ಬೇಕು. x1 y1 z1, x2 y2 z2. Okay. So now the vector form is vector R is equal to vector A. You take this as a one point just like this, plus lambda times the parallel vector is this vector, the b minus a. So this is a vector form of this equation. So what is the Cartesian form? X minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. In a class you have to get this answer yourself by using this vector form and substituting the values. I hope you got the answer. The answer should be this: x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, and z minus z1 by z2 minus z1. So you should get this as a Cartesian form of the equation of a line passes through 2 points. I hope you got this answer. ಗೊತ್ತಾಗಲಿದ್ರೆ ಆಮೇಲೆ ಮೆಸೇಜ್ ಮಾಡಿ, I'll write and send it to your group. Okay, remember that. Yeah, so in last class we just learned the two important derivation. Remember that, very very important derivation. I'm not taking problems now because ಈ textbook ಅಲ್ಲಿ ಹೇಗೆ ಹೇಳಿದೆಲ್ಲ theory ಮುಗಿದ್ಮೇಲೆ problem ಇರೋದು. So I'll complete the theory which is related to straight line in a space, then I will take problems together. Okay. Yeah. So after identifying how to write the equation of a straight line on a plane, on a space, now we are going to find out angle between them. New first piece of straight line allo equations and find out madidmele angle find out madidire alva. So now we are going to find out angle between the two straight line in space. Okay, so different idea, observe carefully. Angle between two straight lines L1 L2 is the angle between, observe this sentence, is the angle between the vectors b1 and b2 which are parallel to the given lines. And then suppose you want to find out angle between these two lines, correct? It should intersect first of all. Okay, I'll write here. We want to find out angle between these two lines, that is theta. Suppose this is theta. Then finding angle between the two straight line in a space is equivalent to finding the angle between the two parallel lines which are parallel to the respective lines. So this is b1, this is b2. So finding angle between two lines in space is nothing but finding the angle between the two vector which are parallel to the given lines. Sariya? See, idu line, idu vector. Innond line higide, idu vector. ನೀವು vector extend ಮಾಡಿ, you will get angle between them. So this angle is equal to this angle. So why we are using this technique? Because see, both from geometry these two angles are same, right? Parallel angles. why we are using this technique? Because the main reason is we know how to find out angle between two vectors already in vectors chapter, and we have one easy method to find out that. Then cos theta is equal to y dot b divided by their magnitude. Maybe that is the important reason why we are finding angle between two vectors which are parallel to given lines. The main reason is it is easy to find out angle between the two vectors instead of angle between two lines directly. Okay, so if the two lines are like this, r is equal to vector a1 plus lambda times vector b1, r is equal to vector a2 plus mu times b2, then angle between these two straight line is nothing but angle between two parallel vector, b1 and b2. And you know how to get the angle between two vectors. Cos theta formula, vector b1 dot vector b2 divided by magnitude of vector b1 into magnitude of vector b2. ಬೇರೆ ಯಾವ ಫಾರ್ಮುಲಾ ನೆನಪಿಟ್ಕೊಳ್ಬೇಕಂದ್ರೆ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಇದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ಆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ನೆನಪಿಟ್ಕೊಳ್ಳೋ ಅಗತ್ಯನೇ ಇಲ್ಲ. You just identify the vector which are parallel to the given lines. ಅದೇನೂ ಕಷ್ಟ ಇಲ್ಲ, ಪ್ರಾಬ್ಲಮ್ಸ್ ಬಂದಾಗ ನಾನು ಹೇಳ್ಕೊಡ್ತೇನೆ how to identify the vector from the equation of the straight line which are parallel to the given line. Got it what I am telling? So that I will tell you how to identify. After that use a formula which you already have lot of experience in vectors. ಅರ್ಥ ಆಯ್ತಾ ಹೇಳ್ತಿರೋದು? So use cos theta is equal to vector b1 dot vector b2 divided by magnitude of vector b1 b2. You will get the angle between two straight lines L1 and L2 when L1 L2 are given in formally, vector formally. Cartesian form ಬಂದಾಗ ನಾನು ಹೇಳ್ತೇನೆ, ಡೆಫಿನೆಟ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೇನೆ, ಡೋಂಟ್ ವರಿ. ಓಕೆ, ಜಸ್ಟ್ ಆಸ್ ಅ ಒನ್ ಎಕ್ಸಾಂಪಲ್, ಓಕೆ, ಅಬ್ಸರ್ವ್ ಕೇರ್ಫುಲಿ. ದೀಸ್ ಆರ್ ದ ಟು ವೆಕ್ಟರ್ಸ್. ಹೀಗೆ ಬಂದಾಗ this will be the position vector of the point on the line. This is the vector which is parallel to the line. Again, this will be the position vector of the point which is on the line, and this is the parallel vector. So angle between them ಅಂದ್ರೆ ಏನು? cos theta ಅಲ್ವಾ? cos theta ಫಾರ್ಮುಲಾ ಏನು? ಓಕೆ, ಇದು ಫಾರ್ಮುಲಾ ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಬ್ಯಾಟ್ ಆಗಿಬಿಟ್ಟಿದೆ, ಏನೋ ಟೆನ್ಷನ್ ಇಲ್ಲ. ಸೊ ಐಡೆಂಟಿಫೈ ವೆಕ್ಟರ್ b1, this is b1, this is b2. Take the dot product. 3 2 into 2 4 2 into 2 into 6 12 divided by their magnitude. ಏನು ಬರುತ್ತೆ? 1 plus 4 plus 4 ಅಂದ್ರೆ 5, 4 plus 4 8 9. okay, 9. Next one, 9 plus 4 plus 36. 9 plus 4 plus 36. So it is 12 plus 12 ಎಷ್ಟಾಗತ್ತೆ? 24 ಆಗುತ್ತೆ. ಕೆಳಗೆ ಎಲ್ಲದು 3, ಇದು 40 49 ಅಂದ್ರೆ 7. 3 1s are 3 8s are. So it is 8 by 7. So theta ಏನಾಗುತ್ತೆ? cos inverse of 8 by 7. cos inverse of 8 by 7. So this is the angle between two straight lines. So this work will become very easy because of the definition. So what is the angle between two straight line? Angle between two straight line is equivalent to angle between the two vector which are parallel to the given lines. Parallel vector easily identify ಮಾಡಬಹುದು. So very easily you can find out angle between them. ಅರ್ಥ ಆಯ್ತಾ ಹೇಗೆ angle find out ಮಾಡೋದು? ಹೇಳಿ, ಸ್ಪೇಸ್ ಅಲ್ಲಿ angle between two straight lines. ನೆನಪಲ್ಲಿ ಪ್ಲೇನ್ ಅಲ್ಲ, ಸ್ಪೇಸ್ ಅಲ್ಲಿ. Understood? Very good. So this is something about like straight line in two different form and angle between them. ನೀವು ಫಸ್ಟ್ ಪಿ ಯು ಸಿಲಿ 6 different form ಕಲ್ತಿದ್ರಿ, ಇಲ್ಲಿ ಅಷ್ಟೇ ಇಲ್ಲ, ಇಲ್ಲಿ ಎರಡು different form ಇರೋದು, then angle between them. So after that we are going to find out distance between the straight lines. So there are two types of distance, shorter distance and the distance. So that I will discuss immediately, don't worry. Okay, so the next important concept, very very important concept, known as the distance between lines. See, last year straight line ಏನು ಕಲ್ತಿದ್ರಿ? 2 dimensionally distance between the two straight lines, distance between the parallel lines. Okay, see, usually ನೀವು 2 dimension ಅಂತ ಬಂದಾಗ distance between them you can find out only when the two lines are parallel ಅಲ್ವಾ? Because ಹೀಗಿದ್ರೆ you cannot decide exactly what is the distance between them. So we learned in last year 2-dimensional straight line distance between the parallel lines. But each chapter ಅಥವಾ 3D geometry space ಅಲ್ಲಿ we are going to find out distance between the lines even when they are not parallel. Okay, first for that we have to learn one very important types of line are known as skew lines. Skew lines. Okay, see, last year 2-dimensionally intersecting line ಕೇಳಿದಿರಿ, parallel lines ಕೇಳಿದಿರಿ, right? Now this is a new term. Okay, it is known as skew lines. I'll explain first. Two lines are called skew lines. Two lines are called skew lines if they are neither intersecting nor parallel. Immediately one doubt by this santa lines impossible. ಯಾಕೆ ಹೇಳಿ, ಯಾವುದೇ ಎರಡು ಲೈನ್ 2 ಡೈಮೆನ್ಷನಲ್ ತಗೊಂಡ್ರೆ either it should be parallel or ಹೀಗಿದ್ರು they are not intersecting, but when you extend it will intersect. 2-dimensionally, other than these two are never exist. In 2-dimensional, other than these two cases definitely not exist, but in 3-dimensional that is exists. Okay, we have lines, a pair of lines or more than 2 lines, they are never intersect and they are never parallel, and such lines are known as skew lines because we are in space now, not in plane. Okay, I'll take one simple example to make this concept very clear. See, in some big metropolitan cities, you can see different types of flyovers. Maybe one for the transportation of the vehicles. Okay, next one for the metro train. Again, maybe above that one is a bus. Maybe you heard Airbus. So sorry, the bus which travel in a track. Okay, so we may have the different layers of the transportation roads. Whether these different layers will intersect anywhere? Definitely no. You know what will happen if they intersect. Whether they are parallel, even if they are parallel, they were never ending. So you can imagine, okay, that is an example of skew lines. In Mumbai cities, definitely you will see different types of different layer of flyovers. They never intersect anywhere. They are not parallel also, because if they are parallel, they never ends. The road never ends, or in some point the vehicle should jump to down. Okay, even if they intersect to flyover intersect, then definitely the accident is okay. The construction is nonsense. So the best example to understand what I mean by skew lines is a different layer of flyovers in a metropolitan cities. In Udupi and Mangalore you may not be able to see, but in Mumbai, Bangalore, definitely you will get such structures. Okay, so skew lines and the two lines are known as skew lines if they neither intersect nor parallel at any point. They never intersect, they never parallel. Such lines are known as skew lines. But board ಅಲ್ಲಿ ಹೀಗೆ ಬರೀಲೇಬೇಕಾಗುತ್ತೆ, ಬೇರೆ ಆಪ್ಷನ್ಸ್ ಇಲ್ಲ ನಮ್ಮಲ್ಲಿ. Okay, because ಇದು 3D lines actually like this. See, they are not parallel, they never intersect. Okay, so this is possible only in a space, not in plane. Okay, so let me take 2 skew lines. Okay, like this. ಬೇರೆ ಆಪ್ಷನ್ ಇಲ್ಲ ಇಲ್ಲಿ, ಹೀಗೆ ಬರೀಬೇಕಾಗತ್ತೆ. I told in the beginning only we are in a space, but I'm writing in a board, it's a 2-dimensional and this diagram is a 3-dimensional, so you have to imagine. So those skew lines example because they are not parallel, and just imagine they never intersect anywhere in this point. Okay, so actually the 2 skew lines are always non-coplanar. They cannot be in the same plane. Definitely the lines which are skew lines are never be in the same plane. They are always non-coplanar, and they are not coplanar, non-coplanar. Remember that. Okay, so skew lines andre gottaitalva. So with the lines which are neither parallel nor intersecting. Got it? Yes, very good. So now after understanding what in by skew lines, we are going to find out distance between the lines, and here we are finding actually distance between the skew lines only. See, when the word the distance between skew lines arise, definitely there will be confusion. See this if I can say these are the skew lines, which distance you will consider? So same thing happened in the straight line. In 2-dimensional, okay, whenever you are finding distance in the lines, we took only the parallel lines because of this problem. But here, okay, it is not compulsory that the lines should be parallel. So even for the skew lines, we can find out that distance. Since there are so many different distances here, the distance were directly connected to the shortest distance. So we are going to find out the shortest distance between the skew lines. That is unique. The shortest distance between the 2 lines here, the skew lines, will be unique here. So we can find out if I use a word distance between the 2 skew lines, they are not okay. That distance is not unique, so you cannot find out. So we are not finding the distance between the 2 skew lines, shortest distance between the 2 skew lines, because that word is unique, or that shortest distance definitely will be unique in skew lines. Okay, I'll show you one derivation. This derivation, okay, it is there in a syllabus, but up to now it is not asked in exam. But formula is very, very important. So up to now ask ಕೇಳಲಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ ಇನ್ನು ಕೇಳಬಾರ್ದು ಅಂತ ಏನಿಲ್ಲ. So be ready to write the derivation of the shorter distance, because it is derived in the NCERT textbook, your textbook. So the exam ಅಲ್ಲಿ ಕೇಳಬಾರ್ದು ಅಂತ ರೂಲ್ಸ್ ಎಲ್ಲೂ ಇಲ್ಲ, but up to from last 9 to 10 years, this derivation is not asked. Okay, but be ready. As I told, you may get anything from the NCERT textbook. Okay, so I'll show you one little difficult derivations of finding the shortest distance between the 2 skew lines. So take 2 skew lines L1 and L2. L1 has vector r is equal to vector a1 plus lambda times vector b1. L2 is vector r is equal to vector a2 plus mu times b2. So here these two are the position vector of the points on the line, and these two are the parallel vector. Okay, the diagram I can write it again. Here I wrote once here, but okay, I'll write again. This is L2, this is L1, this is the point S. Okay, its position vector is vector A1. Okay, this is a point T, and this vector is position vector is vector A2. Okay, let me take this is the shorter distance, the required shorter distance. Illondu vector ide vector B1, illondu parallel vector iruttade vector B2 ನೆನಪಿಲಿ. So ಇಷ್ಟು diagram ಸಾಕಾಗುತ್ತೆ. So 3D diagram ಬರಿಬೇಕಂದಿಲ್ಲ. Okay, so let S be the point on the line L1 with the position vector vector A1. Just now I told T is a position point on the L2 with the position vector A2. So A1 and A2 are the position vector of the 2 points on on the respective lines, that is L1 and L2. Now we have to find out the shortest distance between the two straight lines or the skew lines. Now if you observe the diagram, the shortest distance between the two lines, okay, the shortest distance between the two skew lines is nothing but the projection, okay, the projection word you will kelidiri, okay, vectors last chapter li kelidiri. So the shortest distance between L1 and L2 is the projection of ST. Okay, projection of ST, that is the distance in the 2 points which is given in the line. Projection of ST along the direction of the shortest distance, so here actually the shortest distance between the two lines is nothing but the projection of one vector on another vector. Here one vector is vector ST, another vector is vector PQ, that you can see in the diagram. P and Q ST. Okay, so this is important term to complete this derivation and to understand this derivation. So remember, the shortest distance in the two lines are nothing but the projection of the vector ST along the direction of vector PQ, or the ST is along the direction of the line shortest distance. Okay, so it's easy to understand. See, this is ST, maybe you can just imagine this is ST, this is PQ. So PQ is the shortest distance and ST is, okay, the PQ will be considered as a projection of this vector on this line. You can just imagine like shadow of this line on this plane, or nothing but the distance. Okay, remember that. So now, how to get this projection? How to get the projection of vector ST on vector PQ? See, for that also in vector we learn one formula. Okay, projection of vector A dot B is equal to projection of vector A and B, or projection of vector A on B is nothing but vector A dot B divided by the magnitude of vector B. So we are using that concept and some other concepts of the vector also. Observe carefully. This part is difficult. Listen. The shortest distance between L1 and L2, let it be D. So I'll consider this distance as distance PQ as D. The shortest distance between the two lines will be considered as D now. So if PQ, the magnitude of PQ is the shortest distance between L1 and L2, under the D, okay, this is we are assuming. According to the diagram, what is the shortest distance? The magnitude of the vector PQ. Then PQ is perpendicular to both B1 and B2. Why? See, distance and that distance and the distance between the point and line bandaga, you are going to draw one perpendicular line. So suppose idu P agide, idu line L2 ade, so PQ must be angle drawn by the P2, the line L2 must be 90 degree, otherwise it will not call as a distance. Nenpili ade tara converse, Q in the line L1 draw madidru adu 90 degree agirabeku. So definitely the length PQ will be perpendicular to the two vectors, vector B1 and B2. So but when we compare, we have to compare the vectors only, we cannot compare the vector and the scalar. So remember that the vector PQ is definitely perpendicular to vector B1 as well as vector B2, because B1 B2 are the two parallel vector to the respective lines. So direction of vector PQ is along n cap, or n cap is along PQ. N cap and then unit vector, right hand system. This is B1, this is B2. So n cap will be perpendicular to both B1 B2. So then ಈ ಫಾರ್ಮುಲಾ ನಾನು ವೆಕ್ಟರ್ಸ್ ಅಲ್ಲಿ ಕ್ಲಿಯರ್ ಆಗಿ ಹೇಳಿದೆ. n cap ಅಂದ್ರೆ vector B1 cross B2 divided by their magnitudes ಅಲ್ವಾ. So now what we understood from the diagram, PQ is a vector is along n cap, or n cap is along the vector PQ, one and the same. n cap is a unit vector perpendicular to both p and vector b1 and b2. So pq is also a vector perpendicular to both b1 and b2. So the direction of pq is along n cap, and we know n cap is equal to vector b1 cross b2 divided by magnitude of vector b1 into magnitude of vector b2. ಇಷ್ಟು ಅರ್ಥ ಆಯ್ತಾ? ಇದೆರಡು ಕಾನ್ಸೆಪ್ಟ್ ಬಂದದ್ದು ವೆಕ್ಟರ್ ಇಂದ ಕನೆಕ್ಷನ್ ಗೊತ್ತಾಯ್ತಲ್ವಾ, ಹೇಗೆ ಕನೆಕ್ಟೆಡ್ ಆಯ್ತು ಅಂತೇಳಿ ವೆಕ್ಟರ್ ಪಿ ಕ್ಯೂ ಅಂಡ್ ಎನ್ ಕ್ಯಾಪ್. ಓಕೆ, now see, we know that the distance of pq is d alva, direction of pq is along n cap. So how to represent vector pq? Magnitude in direction, magnitude eno d, direction eno n cap. So vector pq can be represented as vector pq can be represented as d into n cap. Artha aithalva? Very good. Okay, so I consider this as a 1 and pili this sentence as a 1. So from 1 we know that the shortest distance nothing but the projection of one vector on another vector. Here one vector is vector st and another vector is vector pq. So pq will be the projection of vector st on pq. Projection formula just now I told. Okay, it is vector st dot vector pq divided by the magnitude of pq. Okay, so now pq is equal to st in hage bariri pq. See, ಇಲ್ಲಿ ಏನು ಯೂಸ್ ಮಾಡ್ಬೇಕು ಹೇಳಿದ್ರೆ, ಯೂಸ್ a dot b formula. What is a dot b formula? Magnitude of vector a, magnitude of vector b into cos theta. So vector st dot vector pq is nothing but magnitude of vector st into magnitude of vector pq into cos theta, where theta is the angle between them, divided by magnitude of vector pq. So pq, magnitude of vector pq will be cancelled. So remaining is what st, the magnitude of st into cos theta. This is important. So we are able to get a simple expression to the shorter distance between them. That is pq is equal now the magnitude of st into cos theta. So here our remaining work is to find out cos theta. Cos theta ಏನಂತ ಗೊತ್ತಾದ್ರೆ you will get the expression for the shorter distance. I'll show you how to bring the cos theta. See, but cos theta ಅಂದ್ರೆ actually angle between the two vectors. Angle between two vectors ಹೇಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀರಿ? vector a dot b divided by their magnitude ಅಲ್ವಾ, ನೆನಪಿದೆಯಾ? So theta is the angle between vector pq and st. So the cos theta will come like this, magnitude vector pq dot vector st divided by magnitude of vector pq into magnitude of vector st. Okay, pq ಅಂದ್ರೇನು? ಫಸ್ಟ್ ಫ್ರಮ್ ಸ್ಟಾರ್ d into n cap I'll replace pq ಅನ್ನ ಇಲ್ಲಿ ರಿಪ್ಲೇಸ್ ಮಾಡ್ತೇನೆ ಫ್ರಮ್ ಸ್ಟಾರ್. st ಅಂದ್ರೇನು? ot minus os. ot is the distance, the position vector of the point t. os nothing but the position vector of the point s, ಅಂದ್ರೆ vector a2 minus a1. In between what we have? Dot product. ನೆನಪಿಲ್ಲ, the dot product ಬರೆಯೋದು ಮರಿಬೇಡಿ. ಇಲ್ಲಿ dot product symbol ಇಲ್ಲ ಅಂತಂದ್ರೆ you will lose a marks for all the remaining steps. So be careful. So pq and d into n cap dot vector a2 minus a1 divided by magnitude of vector pq ಏನು? only d. ಕರೆಕ್ಟಾ? ಇದನ್ನ magnitude of st ಹಾಗೆ ಇಟ್ಕೊಳ್ಳಿ, ಏನು ಚೇಂಜ್ ಮಾಡೋದು ಬೇಡ. ಸೊ ಇದು d, ಇದನ್ನ ಹಾಗೆ ಇಟ್ಕೊಳ್ಳಿ, ಸರಿಯಾ? ಸೊ ಏನಾಗುತ್ತೆ? d ಈ d ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. So what is remaining? n cap in dot a2 minus a1 divided by magnitude of st. Magnitude of st ಹಾಗೆ ಇರಲಿ, ಏನು ಚೇಂಜ್ ಮಾಡಬೇಡಿ. But now what is n cap? n cap just now I told it is b1 cross b2 divided by their magnitude. So ಅದನ್ನ ಇಲ್ಲಿ ರಿಪ್ಲೇಸ್ ಮಾಡಿ b1 cross b2 dot a2 minus a1 ಹಾಗೆ ಬರಲಿ, st ನು ಹಾಗೆ ಬರಲಿ, divided by the magnitude of vector b1 cross magnitude vector b1 into magnitude vector b2. ಇಲ್ಲಿ ಏನು ಮಾಡಿದ್ರೆ I just substituted n cap. Remember, substituted n cap. Confusion ಆಗಬೇಡಿ, I just substituted n cap. ಮತ್ತೆ ಏನೂ ಮಾಡಲಿಲ್ಲ. Okay, now use the first expression, second expression which we got for pq, that is magnitude of vector st into cos theta. So pq, the shorter distance between them is magnitude of vector st into cos theta. ಇಲ್ಲಿ st ನ ಹಾಗೆ ಇಡಿ. Okay, cos theta ನಮ್ಗೆ ಗೊತ್ತಿದೆ, ಅದನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. cos theta just now we got substitute. ಆಗೇನಾಗತ್ತೆ ಹೇಳಿ, already one st ಇತ್ತು ನ್ಯೂಮರೇಟರ್, one st cancel ಆಗಿ, so that unknown term, the magnitude of st will cancel. So remaining will be the required expression of the shortest distance between the two lines. So what is the shortest distance between two lines? Vector b1 cross vector b2 dot ಬರೀದು ಮರಿಬೇಡಿ, in dot a2 minus a1 divided by the magnitude of vector b1 cross b2. ಇಲ್ಲಿ magnitude ಮತ್ತೊಮ್ಮೆ magnitude ಬರೀತೇನೆ because the distance cannot be negative. Be a safer side. ನೀವು ಇಷ್ಟೆಲ್ಲ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಿ ಆನ್ಸರ್ ನೆಗೆಟಿವ್ ಬಂದ್ರೆ ಡಿಸ್ಟೆನ್ಸ್ ನೆಗೆಟಿವ್ ಆಗೋ ಚಾನ್ಸ್ ಇಲ್ಲ, ಸೊ ಮೀನಿಂಗ್ಲೆಸ್ ಆಗುತ್ತೆ. ಸೊ ಫಾರ್ ದಟ್ ರೀಸನ್ ಯು ಜಸ್ಟ್ ಯೂಸ್ ಅ ಮಾಡ್ಯುಲಸ್ ಸೈನ್, ಸೊ ದೇರ್ ಇಸ್ ನೋ ಚಾನ್ಸ್ ಆಫ್ ಗೆಟಿಂಗ್ ನೆಗೆಟಿವ್ ಸೈನ್ ಇಟ್ ದ ಆನ್ಸರ್. ಸೊ ಡಿರೈವೇಶನ್ ಅರ್ಥ ಆಯ್ತಾ? ಮತ್ತೊಮ್ಮೆ ರಿವೈಸ್ ಮಾಡಿ ವಿಡಿಯೋನ, ಅರ್ಥ ಆಗಲಿಲ್ಲದ್ರೆ ಹೇಳಿ, ಐ ವಿಲ್ ರೈಟ್ ಅಂಡ್ ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಅಗೇನ್ ಅಂಡ್ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್. ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಆಸ್ ಐ ಟೋಲ್ಡ್, this is an important derivation actually, but from last 10 years it is not asked in a final exam. But there is no rule that this question should not be asked in a final exam. You may get it. So every year I am telling this, that you may get this year. So who knows, you may get this one for you in a coming exam, the final board exam. So be prepared for this. But if you not understood, then you can discuss with me, okay, either through WhatsApp or once you come to the college, okay. But ತುಂಬಾ ಜಾಸ್ತಿ ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋಕೆ ಹೋಗಬೇಡಿ, ಕನ್ಫರ್ಮ್ ಆಗಿ ಕೇಳ್ತಾರೆ ಅಂತ ಇಲ್ಲ, ಬಟ್ ಕೇಳೋ ಚಾನ್ಸಸ್ ಇದೆ. So how many derivations over? 2 derivation in straight line and the shorter distance derivation straight line again, okay. ಅರ್ಥ ಆಯ್ತಾ ಇವತ್ತು ಮಾಡಿದ್ದು? ಸೊ ಶಾರ್ಟರ್ ಡಿಸ್ಟೆನ್ಸ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ, ಪ್ರಾಬ್ಲಮ್ಸ್ ಎಲ್ಲ ಸಿಂಪಲ್ ಇದೆ, ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಸೊ ಶಾರ್ಟರ್ ಡಿಸ್ಟೆನ್ಸ್ ಡಿರೈವೇಷನ್ ಸ್ವಲ್ಪ ಕರೆಕ್ಟ್ ಆಗಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ, ಅರ್ಥ ಆಯ್ತಾ? ವೆರಿ ಗುಡ್, ಥ್ಯಾಂಕ್ ಯು.